Right. So today we are going to look at a plugin called Weaverbird. Weaverbird. A topological modeler. So I did a little search for Grasshopper or Weaverbird. Top hit. Let's see what this is. Grasshopper docs. Community documentation for Grasshopper add-ons and plugins. So this is a repro. Tells you all the different commands and stuff. And what we want to do, head to the top right of that page, go to downloads, and that actually takes you to another website which is by the team who created that plugin or individual. And Weaverbird plugin, blah blah blah, for Rhino 6 and 7. Open this .gh file and Rhino will use the package manager to install Weaverbird. So if I was to do that, open location, I do believe all you need to do here is drag and drop, and it will automatically install itself and give you a whole range of demos and explanations. But we are going to forego that today. So I've got a new file open. Going to save it as, I'm going to call it Canopy Weaverbird WB. Save. And I'm going to save my Grasshopper script as Canopy Weaverbird. There we go. So if it crashes, hopefully we'll get a save at some point there. And we really don't have to worry too much about the... Well, let's see what happens. And hopefully this is going to create a tab along the top called WB for Weaverbird. You might have to close Rhino and open it again. I'm not too sure how that works too well. Predominantly focusing here on the subdivision, using the Catmull-Clark and Sierpinski triangles, if that's how you pronounce it. Picture frame and mesh thicken. We use that. Offset mesh can work quite well as well. But we do also have some primitives which can work effectively, and we will also be using the Weaverbird join mesh and weld function to join the triangles of our mesh. So you can see the grid is on. Let's turn that off with F7. And what do I need to do first? So the first thing I might play around with here is a surface in Rhino. I'll create a plane. I'll put it at 0 and I'll make it 100 by, no, start again, 0, 100 by 100. There's my surface. I'll put the viewport into shaded and I'll bring that in using parameter geometry surface. Right click, set one surface, and click, and away we go. There we go. That's our surface. I might even select the object in Rhino and press hide. And for the benefit of all, I'll use bifocal so you can see the nodes. Okay, so what we need to do here is actually use mesh geometry. So using the NURBS surface to define our plane, our base plane, we actually need to now go into the mesh tab, and I believe it is just create a mesh from a surface. It's not that one. Mesh surface. There we go. Utilities, and I can drop that surface in. Hundreds of ways to make a mesh in this software. I'm going to turn the preview off of the base surface, and here we actually want to increase the resolution, or at least be aware that we can increase the resolution. So maybe I'll use around 25 on each, copy and paste that, or drag and alt, and you should be good to go. And as you can see, that grid, the mesh is now subdivided, and we can do that dynamically here. So because it's 100mm square, then I'm sure, well, we'll see, we'll play around, we'll come back to that later. So the opportunity, a few things we need to explore today is, well, let's see, we can first of all turn that on mute. Go straight into Weaverbird and just see what properties that has. Weaverbird, we're going to go into transform, we will use picture frame, and we'll drop the mesh in. Straight away that looks a bit bold. Creates what's called in other software an inset, or colloquially shorthand is a picture frame. And yeah, this is what you could use for curtain walls even back in the day, before you had a button called curtain wall in Revit. And distance might be, what's its current default value? 5. So let's maybe use 15. We can get very, very fine, or we can go nice chunky window frames. And then from here I can hide that original mesh, middle mouse, hide, see that? And then we can go into the subdivide, we could go into Catmull Clark, and we can drag the output into the mesh, hide that original one, and we can see that we are now turning those, well, let's see, the original surface, which are rectangles or triangles, and we are turning them into these more complex arrangement of subdivided surfaces or meshes. And the level here is number 1, and the max that can go up to is 3, I think. So I'll put it back to 1, and then if I move that to number 2, you can see we've got a lot more subdivided faces. 3, and if I go to number 4, it starts to error out. So 3 is the max, and if I zoom out, we've now got this round, softened surface, or mesh, sorry, I keep calling it a surface. But if I actually want to make that 3-dimensional, I can go into Mesh Thicken. Let's give that another 15. So that's a little bit too high for this example. Let's do a 5mm tile, and I can drop that into the Catmull Clark. So this is essentially the operation we're going to be running today. We're going to be playing around with this. However, what we're going to achieve, hopefully, is a little bit more vibrant geometry compared to a plane. We will essentially be using these few tools to create a subdivided smooth object. Now what we can do here as well is get a little bit recursive, and we can copy and paste, and we can drop it back into itself, like into a second node, and then we can achieve a finer result once it calculates. So as you can see, it does take a little bit of computation to generate these forms. And it's probably crashed my machine now, despite it being on paper quite good. Okay, wow, look at that. So yeah, that is quite a dense mesh. Quite amazing that that can do that. Drop that down to, that's probably going to load again, isn't it? Probably should have just undone that as an example. So I'll kill that, don't need that at the moment. Another thing we can play around with here though is maybe if I bring that slider down to say number 2, so it's somewhat smooth. Maybe make the thicken a little bit less. 3, yeah, still a bit chunky. 1 maybe, maybe 2. Oh my gosh. What we can do here, again, you can play around with the thickness of this thing. What could we look at? Creating another picture frame. Don't know if 2 is going to work too well. We could do 0. Let's do 1.500. So we're going to do a picture frame of the subdivided surface. So to make that a little bit thicker, give it a bit more gravity, and here we can see we're really getting into those what do you call them? I keep forgetting the name of those stupid, little sea creatures made of silica. Radioloria. There we go, Radioloria. If that's pronounced correctly, I'm not too sure. So could we go in here and do another mesh thicken? Let's bring that down. Drop it in the distance first of all, and drop that in there. Hide that one. Reveal this one. Right, so 0.9 is pretty dense. Okay, so 0.1, 0.6. We're starting to see something a little bit more feasible. There we go, I'll keep it at 0.1. Yeah, let's do that. Let me reduce the size of this grid. Fewer faces to manipulate, which means I can possibly get a slightly thicker structure. And then, can we even go another level deeper still and put another subdivide? Let's drag that slider. Oh, okay, so this needs to be an integer, doesn't it? Put it to 1. Wowza, look at this go. Number 2, hopefully. So there we go, we went several layers deep. Custom preview, so we can actually see the thing. those fine details. Yeah, I think we should be able to push that to number 3. 3 iterations. So when you're doing something that's quite complex computationally, it's when you're moving these sliders around, you can skip around accidentally. It might be more appropriate to double click on the slider and give the value, type it in. If the slider can actually get to that range, which this one can. Okay. So admittedly, if I was to go around and play around with the number of cells, the original offsets, things like that, meshes, this would eventually break and take an awful long time to compute. So it might be a case of going in here and disabling them, moving around the geometry with just the first level of picture frame or thicken, or maybe the first level of subdivision with a lower iteration value. That way you do have a bit of horsepower left to actually play around visualizing before we go in and turn all these back on so you can actually get the final finish you want without your machine having a mild panic attack. Okay, so as we try and bake this out, it's pretty juicy. Let me put myself into a rendered viewport, which is going to annihilate this PC. Yep, rendered. Turn the grid off. Yeah, it looks alright. I think that regimented grid is not necessarily working for me really, so maybe we should explore trying to put this on something a little bit more dynamic and novel. So, nevertheless, that is quite cool. Quite enjoy looking at that. Should I kill it? Let's save it out. Get more plane. Alright, so ultimately that is it for this exercise. Download Weaverbird, create a surface, turn it into a mesh, and explore some of those Catmull Clark picture frame nodes, and we'll go from there. That said, if you want to do something a little bit more out there, we can certainly try that. Another plugin, well, it used to be a plugin, but now it becomes packaged with the software, is Kangaroo 2. And this is a physics engine in the software. What am I going to do with this? Let me get rid of all those. So we're just left with this base surface. I wonder if I should call it a day, really.